Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. Tell me honestly, have you ever noticed that our periodic table looks so perfectly organized, like a calendar for elements? But do you know that it was not always like this? Scientists struggled for years to arrange elements. My dear student, in our last lecture, we discussed why we need a periodic table and how scientists like Joyner, Newlands, and Mendeleev contributed. But today, we are stepping into the modern era of chemistry. Our topic is modern periodic table. By the end of these lectures, you will know exactly how the elements are arranged in the modern periodic table and why it is so important for us. So, how we reached the modern periodic table? Let's start with a quick recap. What is doing? Mendeleev arranged element by atomic masses, but some elements did in fact perfectly. Later, Harry Moseley and 1913 discovered that atomic numbers, not mass, is the real basis for arranging elements. This gives us the modern periodic law. The physical and chemical properties of elements are the periodic function of their atomic numbers. And using this law, scientists created the modern periodic table. Scientists created the modern periodic table. Now, structure of the modern periodic tables. My dear student, now let's see how this table is organized. Total elements is 118 non-elements. Rows at the periodic table, which is a horizontal line is called row, which is called periods. There are 7 periods in the periodic tables, and the column is a vertical called groups, which is 18 groups, which is 18 group. Now, let's break it down. Period. What's a period? There are 7 periods. Period number uh, is equal to number of shells and atoms. Period 1, elements with 1 shell like hydrogen and helium. Period 2, elements with 2 shells like lithium and neon. Period 3, elements with 3 shells like sodium and argon, and so on. And groups, there are 18 groups in the modern tables. Elements in the same group have the same number of valence electrons and show similar chemical properties. Examples: Group 1 alkali metals, lithium, sodium, potassium, all react strongly with waters. And Group 17 halogen, fluorine, chlorine, bromine, all form salt with metals. Now, blocks of the periodic tables. The modern table is also divided into blocks depending on the type of atomic orbitals being filled. Blocks and filling position and table examples. Now, my dear student, look at the tables. S block are subshell fillings, s orbitals and position and table as group 1 and 2. Example, hydrogen, lithium, sodium. And p block have p orbitals, which is a group 13 to 18. Example, carbon, nitrogen, oxygen. And d block have d orbitals and position and table as transition metal, it is in center. Examples, Fe, Cu, and Zn. F blocks have F orbitals, position and tables as lanthanides and actinides is present at the bottom of tables. Examples, U and TH. This block system makes it even easier to study elements with similar properties together. Now, registering key features of modern periodic tables. Registering arranged by atomic number, not masses. Elements with similar properties fall in the same group. Product properties of new elements. Explain range like atomic size, metallic and non-metallic nature, ionization energy, reactivity. Registering it is considered milestone in chemistry because it organizes the entire chemical world into one logical chart. Now, importance for you as a student. Once you understand the modern periodic table, my dear student, then you can predict chemical properties without memorizing everything, and you can understand reaction more easily, and you will be ready for advanced topic like chemical bonding and periodic trains. So, my dear student, this is all about today's lectures. My dear student, if this lecture help you, then don't forget to like the video and subscribe to the channel for more chemistry lectures and share it with your friends and comment your questions below. Thank you for listening.